the specific heat of aluminum is 0.902 joules per gram per degree Celsius. If a 306.6 gram aluminum pie pan absorbs 145.6 kilojoules of heat to raise the temperature to 183.2 degrees Celsius, what is its initial temperature? So what was it before it was heated? So we have a specific heat, we have a mass, we have a amount of heat absorbed or released, whichever case, and we have a TF. So we're looking for TI. So take a moment to make sure the labeling makes sense and knowing what's what makes sense. If it doesn't, please reach out to me immediately. Okay, so we have Q equals M times C times delta T. Okay, our Q is 145.6 kilojoules, and it says absorbs, so it's positive. Our mass is 306.6 grams. Our specific heat is given to us to be 0.902 joules per grams degree Celsius. Our change in temperature, remember, is TF, which we know is 183.2 degrees Celsius minus TI, which is what we're solving for. Okay, so now we're going to get TI by itself. Please do not do any fancy algebra. Do the algebra you know. Go slow and do the algebra you know. I'm going to show you plenty of steps. You can include every step that's necessary, but you have to be able to do these calculations algebraically correct. Currently, grams are going to cancel, right? Because I'm going to multiply those numbers when I do that, grams cancel. So we're going to be able to multiply these numbers out in front. 306.6 times 0.902. And I get, and I'm going to be able to do 3 sig figs here, I get 278, let me try that again, 277, I round it wrong there, 277 joules degrees Celsius times 183.2 degrees Celsius minus T sub I, and this is still 145.6 kilojoules. Okay, so I don't want to distribute if I can avoid it. There's no reason to distribute. I can divide instead both sides by 277 joules degrees Celsius. Okay, now before I divide that, I'm going to recognize when I divide that over, I'll have kilojoules on top, right? So thinking about it like this, 277 joules degrees Celsius, right? But I have joules and kilojoules, those won't cancel. So I'm going to take a moment to convert my kilojoules into joules. So I'm going to go over here, I'm going to take 145.6 kilojoules. And I know for every 1 kilojoule, there's 1,000 joules. So this becomes 145,600, move it 3 times, 1, 2, 3 joules. Now I can use this division and it'll work. So 145,600 divided by 277. Remember, on this side, things will completely cancel. Over here, we're going to get, with 3 sig figs, 526 degrees Celsius, because that unit will flip up. Think about that. We have joules over degrees Celsius, so that's the same thing as joules over degrees Celsius joules, so joules cancel because I'm flipping it, right? When I divide a fraction by a fraction, I flip it. Okay, equals 183.2 degrees Celsius minus T sub I. So now we're going to subtract 183.2 degrees Celsius from both sides. And we can do this because we have the same unit. So 526. Now if you're not rounding off your calculator, you'll be slightly different than me. And I'm going to get a positive. Over on this side, I'll get 342.8 degrees Celsius. I'm not doing a very good job with sig figs there, but that's okay. And then we got to divide. We're not done yet. We solved for negative T sub I. Got to solve for T sub I. So we're going to divide both sides by -1. That gets the negative. And my initial temperature then, that pan was very cold. Must have been in the freezer, deep freezer. Negative 342.8 degrees Celsius. That would be my final answer of temperature.